Well, thank you for coming. So yeah, we're going to start sort of a brief explanation on Moonbeam and the workshop that we've put together. This is jointly with Manta, which is another parachain on Polkadot, but sadly they could not be here. So yeah, the idea is that if you're not familiar with how Polkadot works, is that Moonbeam is a smart contract parachain on Polkadot, but it doesn't have privacy built into it, right? It's just a smart contract platform. But the idea is that in Polkadot, you can have, is this a pointer? Oh, it's a pointer? I'm not sure. Anyways, the idea is that you can have parachains like Manta, which can provide a privacy layer, but they're a separate blockchain completely, right? And you can communicate these two blockchains via a protocol called XCM, and so that's why we call it privacy on Polkadot via XCM. So, yeah. We need to talk about Polkadot, right? Because Polkadot is basically where everything is happening. And so Polkadot, basically the idea is that you don't have one blockchain to rule them all, but you have an ecosystem of blockchains that are secured by the same core layer or layer 0, which is called the relay chain, which is actually what Polkadot is. Polkadot is a blockchain for other blockchains, basically. And the role of Polkadot is basically two things, generally speaking. First, it actually secures these blockchains, providing consensus to them. But because of this architecture, you can actually have them interoperate under the same consensus umbrella, right? So you're asking one blockchain or parachain to send a message to another parachain, creating state changes, but these state changes are going to be governed or verified by the same consensus in both cases. And so you create an ecosystem of blockchains which each provide something unique to the entire ecosystem, right? So you have Moonbeam being an Ethereum-compatible smart contract parachain. You have Manta being a privacy layer based on ZK technology. And then you have other parachains like storage, identity, bridges, oracles, etc., right? And like I said before, the key technology that it's used to communicate these parachains is called XCM. XCM is a very generic term, but it's what allows these participants to communicate with each other. So let me explain briefly how developers can interact with Moonbeam, right? If you think about Ethereum compatibility, you can for sure see a person, let's call the person Bob or Alice, and then that person can interact with Moonbeam using the Ethereum API, right? That's like Ether.js, Hardhat, MetaMask, Remix, all the tools that you're familiar with, even a ledger device through a wallet or whatever. That is what allows you to build Solidity smart contracts and not having to change anything of what you're familiar with if you are. But on the other side, Moonbeam is built on Substrate. If you're not familiar with Substrate, it's like an SDK, generally speaking, to build blockchains, and it's very customizable. You can do a lot of things, but it also provides another interface, right? A separate set of interface in which you can do staking, governance, XCM, or other things that are not native to the EVM, right? So you can do native staking or native governance or native stuff that it's outside of the EVM realm, let's say. And so the way that we actually allow EVM developers or Solidity developers to tap into that complex interface that is not known by the EVM is through precompiled contracts, okay? The idea of precompiled contracts is that there are interfaces, EVM interfaces. Right now we have them in Solidity, but we could have them in Viper or whatever, in which you can access functions that are going to do a lot more complex stuff under the hood because they're going to do Substrate things, right? So you can, for example, send an XCM message using MetaMask, signing with MetaMask. You can stake, you can do governance, you can do batch transactions as one single transaction. So as a summary, you can do things that are not standard EVM interactions through like an EVM or Ethereum-like interface or experience, which is what's really cool about Moonbeam, that it's not just another EVM chain. It has special things, special features. So that's why I say that precompilers are like having the best of both worlds, because if you're familiar with Solidity, Ethers, Hardhat, you can still use that. And I brought a dApp as an example that you're just going to use MetaMask, but you're doing much more complex things. So this workshop, this idea, the presentation is going to be somewhat brief, and the idea is to show you a dApp that you can use as a baseline for the bounty, because it's like 3 p.m. or 2:30 p.m. and you have like 12 hours to build. And so I've done a lot of work to help you guys get started and get you interested in the bounty. But let's talk first about XCM and especially remote transact. What is it, okay? So at a very high level, this is super simplified because as developers, you know, it's like if you want to build and you have to learn opcodes, which is a great thing to know, but you don't really necessarily need to know opcodes to build smart contracts. At a very generic level, what XCM is, it's a message with instructions, right? And it's a combination of instructions that actually do something. So one instruction can be stand up. By itself, it doesn't mean anything. But if you have a combination of instructions like stand up, walk to the left, and flick the switch, 3 instructions, you're going to have a meaningful action. Okay, so at a very high level, that is what XCM is. It's a message that has instructions, and it's directed to another chain. It could be within the Polkadot ecosystem. It could be outside of the Polkadot ecosystem soon because they're doing upgrades to enable that. Okay, and so as an example, I brought here a series of XCM instructions that actually really do something on Moonbeam. So one use case of XCM, which is very famous, is token transfers. That's the first thing that everyone likes to do, I guess. And once again, there's a combination of XCM instructions that result in tokens being transferred. And the one that we're going to focus today is remote execution, okay? So the idea of combining XCM instructions so that you can execute code on another parachain using XCM. And that's what's really important here, because if you think, one of the first slides is that Moonbeam, it's an application layer, it's an application blockchain, and then Manta provides a privacy layer on top of it, right? So imagine you build your application on Moonbeam, but you want to privatize certain aspects like payroll. You could build that privacy layer on Manta via XCM. And so this is how remote transact or remote execution works at a very high level once again. You have Alice on Polkadot. I should have used Moonbeam to be honest, but I had this example from before. You have Alice on Polkadot, and she's going to send an XCM message with a few instructions. Like I said, you don't need to understand the instructions for now, to Moonbeam. And what's going to happen is that when the XCM is processed on Moonbeam, there's going to be a new origin, a new dispatcher, okay, that's going to be created automatically by the protocol. And this dispatcher is going to be known as multi-location derivative account. You're going to put that thing on your brain because I'm going to be referencing to it quite a lot. MDA, multi-location derivative account, however you want to call it. But basically, this dispatcher, all right, it could be a message sender in the Solidity environment. It's basically calculated from the origin on Polkadot. And I'm going to show you briefly how. And so now this dispatcher is going to actually execute the XCM, well, it's going to be the message sender of the XCM, and then you're going to call some bytes on the runtime that are going to do a certain action. And this is, once again, at a very high level, how remote execution works on XCM. What you need to know is what bytes are you calling on the target chain. Okay, that could be call this smart contract and do this, call the staking module and do that. So that's what you need to know. The bytes that you're targeting on the destination parachain, okay? And if you think about it the other way around, so if Alice would be on Moonbeam and this would be Manta, right? On Moonbeam, you can create the XCM message through this precompiles that I've mentioned before, so you can actually do this, from a smart contract or sign this message from MetaMask and so on. So the multi-location derivative account is basically calculated with a hash, right? So that way you know that it's a one-way operation. And then it's the hash of something called the multi-location. And I'm going to explain multi-locations in a little bit more detail later. But as a sort of introduction to multi-locations is a way to reference things on Polkadot in a generalized way. You have an ecosystem of blockchains, an ecosystem of users, of tokens, and so multi-locations is a way that you can represent anything that you can think of inside of this huge ecosystem. So in this case, there is a multi-location that is specific to Alice on Polkadot. You don't really care what account ID Alice has, what hashing they use, or what cryptography they use on Polkadot. You don't really care even if it's Ethereum compatible, right? But on Moonbeam, once you get that multi-location, you can hash it, we use that mechanism, and we're actually proposing this to be a standard in Polkadot. You can hash it, and then you can guarantee, because you're cutting 20 bytes, you can guarantee that this is 160-bit long, or 20 bytes. The hashing doesn't really matter. I mean, as long as a one-way hash, it's strong enough. And then you can guarantee that it's Ethereum compatible, because 20-byte addresses are Ethereum compatible. Yeah, so this is multi-location derivative accounts. It's a way that you, if you think about the example I was saying before, you can actually control another account on another parachain or another blockchain without having to move to that blockchain, right? So this is actually the example that we're going to do later, and I actually have a tutorial on the Moonbeam documentation when I'm doing Uniswap v2 swaps on Moonbeam, where I'm actually initiating the swap on Polkadot. So I don't even have to have MetaMask or anything. I'm just doing everything via XCM and this multi-location derivative accounts. All right, so keep that term in your head, because we're going to refer to it later in our demo. So this is at a lower level now how the remote transact works. And this is important because even though you don't really need to understand it at a very high detail, you still need to know a few terms and terminologies, because you're going to be configuring a little bit of this XCM messages. What's really important is what happens on the destination chain on the XCM messages. And remember that I said that XCM are a series of instructions, right? These are the instructions that normally are received by the destination blockchain, okay? In this case, Moonbeam or Manta. The first one, it's basically what creates this multi-location derivative account, okay? So it's basically that this is what you're saying, this is Alice on Polkadot or Alice on Moonbeam or whatever. The second one, it's going to take funds out of this multi-location derivative account, and it's going to put them in something called the holding registry. The way that I like to say it is that, I take money out of my pocket and I put it on the table, just to put it there, because we're going to use it by another instruction, right? Remember that an instruction by itself doesn't mean anything, but a combination actually results in something. The next instruction is actually, you're going to grab some of the money on the table and you're going to buy execution with it. You're going to buy block space or execution time, however you like to refer it, right? And so you're saying, I am paying so that I can execute stuff. And the last one is basically, I want to grab these bytes that represent something in your blockchain and execute them, please, okay? And so some parameters that you can think of that you need to configure is how much money I have to take out, how much execution time I want to buy in seconds, basically, and how much execution I want to buy for the transact, right? So let's say it's like gas limit. You can think of it as like gas limit, right? I want to buy 10 million gas units, and then I want to use 5 million of those gas units for the transact, basically, okay? This is like an analogy on Ethereum. Cool. So multi-locations. Like I said before, this is a way that you can sort of represent anything on Polkadot with a single representation. The way that I like to see it is like folder paths, right? I mean, maybe it's a good idea, maybe not. But basically, you define a target from an origin, right? If you're in, your user folder and you want to target another, you would just go cd, blah, 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 and get to it. It's relative to an origin. It could be absolute as well, but to be honest, it's a lot easier to understand multi-locations if you think it from a relative perspective. And like I said, you can represent everything with two simple things. Parents, which I like to see it as hops to an upper level, like an upper folder, like a parent folder. That's why it's probably called parent. And then interior, which is a way that you can represent what it's on that current level, okay? So let's go through some examples. Let's say you're in Polkadot and you want to target an account. You want to target Polkadot itself. This is how you would represent Polkadot. In parents 0, because you're still in the same level, and they're interior here. That's like a type of interior. There are like many types of interiors. They're predefined, basically, okay? If you want to target Bob on Polkadot, you would say parents 0, but then interior, I would put X1. I only need one field, basically, to represent Bob. Is it Bob? Yeah. And it's basically the account type of Bob, which in Polkadot is called account ID 32 because there are 32 bytes. Sorry. If you want to target another parachain, you would actually just use one field inside interior called parachain ID, which is like chain ID. and you would just put the parachain ID, which in this case, I used Akala, and it's 2000. And if you want to target Alice inside of Akala, you would actually use two fields, right? Because you need to go to the parachain, and then you need to go to the account, which is another account ID 32. In the case of Moonbeam, it's very similar. The main difference is that we use Ethereum-style accounts. So you would put account ID 20, right? And there's also a way to represent this like complex multi-locations in like Solidity smart contracts. But basically, you need to know that there are like different account types, and then you can also represent assets by adding more fields and so on. Really briefly, if you now the origin is now Moonbeam, right? You can get to, well, now inside Moonbeam, you don't need to put parents, right? And you need to put X2 now because you're inside Moonbeam. But if you want to get to Polkadot, you have to use parents 1. You're moving to an upper level in the folder. And if you wanted to go from Moonbeam to another parachain, you have to use parents 1 because you're moving to an upper level. But now you have to then keep everything else the same. All right, this is quite simple. And like I said, I brought examples and everything to help you guys. All right, so building multi-locations from precompiles on Solidity, right? So this is how, if you're gonna interact with XCM on Moonbeam using the precompiles, this is how you actually build it. So the way that we actually do it is basically, it's an object, as you can see. The first element of the object is a uint, basically, sorry, it's a Boolean, or it's a uint actually, which in this case is only 0 and 1, but it's not a Boolean, it's a uint. And you can put 0 if parents is 0, 1 if parents is 1. Because we're targeting another parachain, right, from Moonbeam, think about the folders, and so now you have to put 1. For the other part, the interior, the X, X1, X2, X3, it's the size of the array. And then basically, if you want to target another parachain, in the documentation, there's a list of how you build it. But basically, you have to put a selector, which is, in this case, to provide a parachain ID, it's 0, 0. And then you would have to put the parachain ID, which is more or less a chain ID, in hexadecimal. And it's in 4 bytes. So that's why it's 0, 0. I think I do have it here. So 0, 0 for the selector, and then 0, 0, 0, 0, 0, and then the parachain ID in hexadecimal, okay? And this would be actually, maybe this is actually Manta's parachain ID. I might have confused myself a little bit here. But the important thing is a structure, right? Basically, this is the multi-location when you want to target another parachain from a Solidity perspective. If you want to target another account, look that it's fairly similar. You have parents as 1. Oh, there you go. Anyways, you have parents as 1, and now you have the array needs to be X2 because we need 2 fields to define it, the parachain ID and the account, right? And so you could see that the parachain ID is the same as before, and then the account is built with this complex structure, which is basically 0, 1, 0, 0 is parachain ID, 0, 1, it's an account key 32, an account ID 32, which is the Polkadot style accounts. And then we provide the account, which is this 64 bytes, or 32 bytes, 64 hexadecimal number. And then we have the network type any, which is those 2 zeros at the end. These 2 zeros, you can always keep it like that. So basically, the important thing here is 0, 1 as the account ID 32, and then the account itself. In this case, it's the multi-location derivative account because that's the account that we're targeting, for example, to send tokens to or whatever you want to do. This might make a lot more sense when we're actually doing it in the DApp example, okay? But just keep in mind that this is X2 because the array is size 2, and then you have the 0, 1 account and then 0, 0. Cool. And then this is the part where you can actually think, and this is where you can do whatever you want. And this part, you can do exactly whatever you want, because this is the bytes that you want to use in the transact. So this is the bytes that you want to execute on the target chain, right? So if you're building privacy applications on Manta, you can say, hey, I want to call this palette privacy blah, 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 and then mint a private asset or whatever, okay? So in here, you can do anything that you want. In the example that I brought, I'm going to do a simple balance transfer because, you guys got to do a little bit also like on the privacy layer. But as an example, it was just a simple balance transfer. And so if you're familiar with Polkadot, this might ring a bell, which is basically we're creating an API provider. This is similar to like the Web3 provider in Ethers or Web3 JavaScript. And then once we have the API provider created, and the last or the one before the line, you can see that I'm calling the function with the destination address and the amount that I want to do, and then the call data I get it basically by using method to hex. So basically here you can say whatever function that you want, and then if you add this method to hex, you're going to get the call data, right? So that can be anything, like I said. It could be what it's called a system remark. It could be call the private palette and then whatever method, right? So this is where you can get creative and do like, weird applications on top of Manta, for example. So this is the demo app that I worked for you guys to show you more or less. By the way, at the end there's going to be a QR code with like the slides, and then, so you can get access to all of it, right? So this is the dApp that I created for this purpose. You don't have to use it, but like I said, you have like 12 hours to finish it up. So this is like a good start if you want to start building on the bounty. So yeah, let me show it to you because it took a while, to be honest. I'm not a programmer, by the way, so this is a very simple UI. This is not pretty, but it works, which is helpful. I'm gonna actually, let me take the mic with me, hopefully. There we go. So basically, the dApp, it's super simple. You need to provide the WebSocket endpoint of the parachain that you want to target. In this case, it's Manta's parachain inside of our testnet. So we do have like a Polkadot, we have a Moonbeam, and we have a Manta. This is basically the token. I didn't explain this because of complexity, but when you're doing XCM, someone has to pay for it, right? I mean, it's not free. And so basically the way that it works is that we have a Manta token representation on Moonbeam, which is an ERC20-like token. And this is the contract of that ERC20 Manta, okay, basically, okay? And I left the addresses here so that you can use it as a reference as well. And then this is basically I'm going to do a balance transfer as a demo. And so for me, when I was trying this application, it was really helpful just to type it out here so I can just copy and paste, all right? But if you want to try it yourself, you can put your address. That doesn't really matter. When I connect, I can do it from scratch, but for the sake of time, I connected MetaMask to it. So I have MetaMask connected to my amazing decentralized application. This is the account that I have on Moonbeam. And you can see that the application actually calculates the multi-location derivative account, and it's displayed right here. All right, this is my super long multi-location derivative account on Manta, which I control via XCM on Moonbeam, okay? I don't know the private key of this account. I have no clue what it is, but I know that I can control it using XCM. And so I've put a lot of URLs, right? A lot of click here, so you can check the code and use it yourself, because I feel this is helpful for you guys if you want to build an application. But basically, this is how you calculate the multi-location derivative account. You click here, and you get into the code on GitHub. I wanted to put it on the page, but I finished this 2 a.m. last night. So, and then you have 3 simple buttons. The first one is we're going to send a token transfer from Moonbeam to Manta to my multi-location derivative account, okay? Why? Because when we actually execute a transact on Manta, this account is going to pay for the gas fees, let's call it gas fees, on Manta, right? So it needs to have funds, because if it doesn't have funds, who's going to pay for it? It's going to fail on execution. And so this action right here is necessary so we can fund our next action, okay? If you do it one time with the $1 million, you can forget about funding it multiple times. But in the demo that I brought, this actually, for example, funds it with 1.5 tokens or something like that. And this balance transfer is for like 1 token, and so it's very on the limit on purpose. And remember when I told you that in Moonbeam you have a lot more than just a simple EVM? And this is one of the beauties that we have, that it's still quite used by developers, to be honest, but it's a way that you can batch multiple transactions into one transaction that you sign on MetaMask. That exists on Ethereum right now via multi-call, but the difference is that you got to do it through a smart contract, right? So the caller is the smart contract. But on Moonbeam, you can have a way that an EOA, a user with MetaMask, Ledger, whatever, can sign a single transaction and then do multiple calls in one single transaction. The beauty of it is that in this particular scenario, right, imagine that you have to ask a user to sign 4 or 5. That's a terrible user experience. It's terrible, and we got to start thinking about user experience, right? It's not great when you're like, oh yeah, I'm going to play a game, and then you have like, bam, 5 pop-ups, 6 pop-ups. You have signing transactions. With the batch precompile, which you have the code here of how you can batch actions, you can just have one action and that's it, you know, and you can batch as many as you can fit in a single transaction per gas limit, okay? So let me show you a little bit of the experience of the dApp, and then we're gonna go into the code just a little bit because, you know, I don't wanna bother you with code, but I'm gonna do it manually and then I'm gonna do it with a batch. So if I click here, you know, I get MetaMask, I am going to sign it, and then I'm gonna go to, if you have ever done Polkadot stuff, this is like your second home. This is Polkadot.js apps, Substrate portal, whatever they want to rename it to. But this is basically like a block explorer and like an interface for like Polkadot-based blockchains. So you can see that I have a message, an XCM message being sent, and then I transfer some tokens to another parachain. That is what this is showing me, even though, you know, you just have to trust me on this, basically. So now, I am sending, Alberto is sending some tokens. You can see that this is the multi-location. I am sending it to basically Manta. And then down here, you will see that I'm actually putting an account as well. And then if I go on Manta, I'm gonna have basically an event, which is basically saying, hey, you have deposited this amount of tokens because I sent 1.1, but I have to pay for fees. You have sent 1.1 tokens to this multi-location derivative demo, right? So this is the account that is derived from Alberto on Moonbeam, and only I can control it via XCM, and I have funded it with tokens, okay? The next step in the dApp is to click this button here, and then I am gonna control that account, right, which I don't know the private key. I'm gonna control it basically from Moonbeam. I just sign a MetaMask transaction, and then what's gonna happen is that you're gonna see that this account that I have here, which has 1.09 Manta tokens, it's gonna transfer 1 token out of it, all right? And it's gonna get killed, basically, because of something called existential deposit. But what I wanna show you is that I'm doing this completely remotely. I didn't go into Manta and I executed the balance transfer. I am doing this from Moonbeam, right? So if you build an application, just think about what that means for user experience. It's a lot cleaner, right? So you can see once again in my Explorer here that what I've done is basically I have withdrawn this for fees, and then my multi-location derivative account transfer 1 token to another account that I had there. It's called Alberto Test. And yeah, and I did that from Moonbeam, right? And so once again, Moonbeam can be the application layer, and then Manta can be the execution for privacy stuff. You don't have to do a balance transfer. You can do a lot more than a balance transfer there. I think I mentioned that I had a Uniswap v2 swap, you know, from another chain, and I also had, we also have another example, which is remote staking, right? So you can do anything that you can do on Manta itself, you can actually do it from another blockchain, okay? So now let me show you the experience of doing everything in just one transaction. I mean, it's not gonna be mind-blowing because you already know what's gonna happen, but it's a single call. You can see that I'm now calling a different contract address, which is a batch precompile. And what this is doing is saying, okay, so I know that I have to do this first and this second, and I'm gonna send 2 XCM messages on the same block, which are gonna get to Manta, gonna be executed in that order. Order is important here, because if I try to transfer without having the funds, it's gonna fail. And then we're gonna have the exactly same effect, but everything wrapped into one block. A better user experience, you know, it's more efficient as well from an application, you know, waiting time perspective, or however you wanna call it. Yeah, we already have it here. So this is basically the XCM message. Maybe we can look into it just to understand that there were actually 2 XCM messages executed. But yeah, there should be 2 XCM messages executed. We have the first one here and the second one here. And at the end of the day, it was basically the same. That's the same one. This is a token transfer, and this is a balance transfer one, as you can see, okay? You can batch as many as you want. I think we have no limit right now. The only limit is the gas that you can get. And as you can see, the application estimates, like the tech, let's say, estimates the gas for you, right? I mean, where can I see this? Market, advance, edit. You can see the gas limit here. Maybe too small, but it's 107,000 gas units, right? So it's already estimated for you. You don't have to worry about the gas limit that you're doing on this call. All right. Oops. Probably because I rejected it. Let's go a little bit into what part of the codes are we using here. This is basically what happens when you click on the button X tokens, right? So this button that it's sending the token transfer from Moonbeam to Manta, right? Remember that this token lives on Moonbeam as an ERC20 token, but you're not going to call an ERC20 token method. You're going to call what it's called the X tokens precompile. Is the precompile that allows you to send tokens to other chains, okay? And so a lot of this code is going to be very familiar because this is all Ether.js. I didn't use any particular library or anything in particular. I basically create an instance of the contract in another function. You can go and check it out, but it's nothing special, using Ether's contract, blah, 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 passing the address, ABI and bytecode and everything. Then I call this function that I'm going to show you. This is to get the call data, so the inputs of the function. I just put it, for a cleaner sort of perspective, I put it somewhere else. And then I do a typical, I have the contract instance here. I just call the function with the inputs that are required. The inputs are basically the ERC20 address, or what we call XC20 address, the amount of tokens that you're transferring. The multi-location that I showed you before is this like object that has parents and interior and everything. And then you have the weight, which is like the gas that you need for the call. But in Polkadot, we use a term called weight, which is instead of being opcode, by opcode, it's like the execution time that it takes. You can use the one that I use as a standard. If you want to transfer tokens, it should work, which is 4 billion picoseconds, okay? And then, as any other Ether.js thing, you just grab the method, you'll wait for it, and that's it. And you would actually get, I didn't print it to be honest, but you would get an Ethereum transaction hash. You can check it in Moonscan, which is Etherscan on Moonbeam, and everything would work as an Ethereum experience. If you go to the X tokens call data, you can see here that to get the amount, I basically call the decimals function of an ERC20 just to get the number of decimals. I had to do this like this because for whatever reason, big numbers were not working for me last night. So I had to do it like this, which I'm just saying, 1.1 times 10 to the decimals just to get, the number in the way units or however you want to call it. And then this is the amount, this is the weight. This is like the gas limit that I was mentioning before. You can use this as a constant. And then here is how we calculate the multi-location. You can see that this is all comments, me explaining how to do it, but the actual multi-location is this, which is parents, all right? This is the selector, like I was explaining before, parachain ID, and then just 4 zeros plus the parachain ID to hexadecimal with a pad start just to make sure that I add the extra 0 here. And then this is the second element of the vector, which is an x2, which is 01 plus the contract, multi-location derivative account, and then the 00 at the end, right? So you can use this as a reference. It is explained there. I'll be there outside if you have any questions or anything on how to build this multi-location in JavaScript or TypeScript or Solidity. The next element I want to show you, and it's very, very similar, is a transact, right? So the button that actually executes the bytes of data in the other blockchain. So once again, it's very similar. We get the instance of the contract. We call a function just to get the elements that we need to the actual, function that we're calling on the smart contract, and then we await for the transaction. Very similar to any Ether.js deployment scripts or transaction interaction script. This is where the meat is. Basically, once again, we need to get the amount. This amount is basically how much money we're going to put into buying execution, right? So we're buying execution to actually be able to execute some functions. And then these values you can use, basically these values you can reuse. That's completely fine. These are going to work. If it doesn't, let me know. But where the important part is basically on the multi-location here, right? This is how you are saying, hey, I am targeting Manta as where I'm going to transact. But also, this is the very, very important part. This is the call that you're doing on Manta. In my case, it was basically a balance transfer, a destination and amount, and then you need to, like I said before, wrap it up in this method so that it gets you bytes that you can execute, okay? So this is where you can get creative and do, like I said before, privacy stuff, so that you can also do the Manta bounty, basically. But yeah. You don't have to get the call data like this. This is not necessary. Manta provides an SDK called Manta SDK, which actually returns the bytes as well for you, and it's easier to use if that is something that you would prefer. This is just a way that I do it, but there's multiple ways of doing it. Okay. Let me see what I have here. Oh, this is the batch. So if you're interested in using it, I feel it's great. It's not super complicated at the end. It's almost similar as the one before. We basically get the call data. So we create the instances of the 3 contracts. We create the call data of X tokens, which is the one to send tokens. We get the call data of the transactor, which is the one to remote execute. And then basically we use the same old like Ether.js code, where you can actually get the call data of the function, so the data that you're trying to execute, using encode function data, providing the function name and the inputs. And you do this for both, for the one to transfer tokens and the one to remotely transact. And that's it. Basically, then the batch is another contract. You can see it as another smart contract in which you call the batch all function. And then the batch all function, it's basically has inputs. Right, as a smart contract, normal smart contract, nothing special, okay? But yeah, sorry if some of the comments don't make sense. I didn't check on them too much, to be honest. Hopefully they do. So yeah, this is how you basically batch transactions on Moonbeam, and it's fairly simple. It's fairly easy. And this is how you calculate the multi-location derivative account. In this case, it's from a Moonbeam origin, right? So the origin has to be Moonbeam. This is how you calculate it, and this is how you basically return it. It's all there in case you want to check it out. Like I said, it's in the application that I built. Let's go a little bit on the bounties. I think this information was shown yesterday, but because we have time, we can show it to you guys. So you can see a description of what Moonbeam is, what Manta is, but I think here is what's important. The general purpose of the bounty is to create a privacy-focused application that utilizes Moonbeam as a baseline application blockchain and uses Manta as a privacy layer, okay? On the Manta, you can use Manta Pay, the Manta SDK, around soul-bounded NFTs. So, anything that uses privacy on Manta will work. From Moonbeam perspective, we'll judge sort of like how the application is built on Moonbeam, and from a Manta perspective, they will actually check the privacy part of it, okay? Yeah, the general judging guidelines is that we want originality and innovation, user experience. That's why I showed you guys the batch precompile. Provide a clean user experience. I know that you have 12 hours, but just focus on that as well. Technical complexity and level of completion, because it might be not complete, but anyways. And you have a lot of documentation. Because I'm here, to be honest, I would focus on the documentation on Manta, right? So Manta SDK, Manta Signer, and how you can get this Manta call data. I can help you guys on the Moonbeam side if you have any questions. I am Alberto, by the way, if you arrived a little bit after I started, I'm Alberto, and this is my Telegram. If I'm not around, you can ping me on Telegram, and I should get to you quite quick. So yeah, I think at this point, I don't have anything else. Oh yeah, by the way, okay, so you might ask yourself, how do you get DEF tokens? DEF is the token of our testnet. So it's Girly ETH, Sepolia ETH, whatever ours called DEF token. And you might ask yourself, how do you get Manta tokens, right? Because you need to pay for execution on Manta. So I think I have it in the application. Forget about this error here, but in the application at the bottom, might be too small for you guys, but there's a faucet link here. And then this link here will take you to a Uniswap v2 fork that we created some time ago. And then there's a pair of def tokens and Manta tokens. So if you get some tokens on the faucet, and then you just say, hey, Alberto, I want to, so hey, Moonbeam swap, I want to put 1 dev token, you're going to get 2 Manta tokens. I'm a whale, so if you guys need anything, I can shoot you as well. So I mean, that's fine. This is just in case it's like 3 in the morning. I'll probably hopefully be sleeping, and so you need some tokens. You could get them there. Okay. I should actually probably put more liquidity on the Manta side so that you can get more tokens. Actually, I'll do that after the presentation. So yeah, I've talked long enough, to be honest. Are there any questions? Anything in particular? Any comment? And yeah. Yeah.
Like XCM, is it?
Yeah.
Okay.
Yeah.
So
yeah.
what? How come you have to use? Is it? But it's not like you could use any token bridged over to Moonbeam, correct?
Yeah. So I mean, this was me yesterday at 1 in the morning saying, how are you guys gonna get Manta tokens, right? Because I mean, I could tell you, yeah, go to Manta and bridge it from Manta to Moonbeam, right? This is all tested, by the way. This is doesn't have any value. But this is like how we can create a faucet for Manta tokens so that you can guys play with on the bounty. And so the way that parachain tokens are represented on Moonbeam are like ERC20s, right? And because they're ERC20s, you can add them to like Uniswap, for example, right? And so this is basically the actual Manta token that exists on Manta, but I've bridged it via XCM on Moonbeam, okay? And yeah, I mean, it takes like 6 seconds to do it via XCM. So.
Okay, thank you.
Yep. Any other questions? Yeah, go on.
I was just thinking, this isn't really a question, but since there was a few people who just did arrive later, do you want to maybe just share again the upper, like sort of the top level of that project? Just like,
yeah. So I mean, do you mean the DApp?
Well, yeah, it's just sort of like going back to kind of that earlier part where you were just talking about like the general overview of what this project is.
Oh, okay, like general.
If that's okay.
Yeah, that's fine.
I know there was people who came late.
Yeah, no worries. Yeah, so okay, so let me go back. And by the way, like I said, if some of you want to leave because you already saw this, let me put this slide first. So this is a QR code where you can get today's presentation. In today's presentation, you have a lot of content, so yeah, sorry about that. Here you have also the bit.ly link to the slides and the bit.ly link to the Google Doc for the bounty information, okay? So if some of you want to leave just because you already watched this, you can get with this information. I already see some people open it because you can see the logo here, so. All right, so, and in here you also have, like I said before, the link to the DApp. And in the DApp, you have a lot of like click here, just trying to be helpful for you guys. But yeah, let me explain really briefly. I'll skip some slides, but the one slide, I'll handpick some slides, okay? So first, what you need to understand is it's briefly how Polkadot works, right? So Polkadot, it's an ecosystem of parachains, of blockchains, right? There's no one blockchain to rule them all. There's no one perfect blockchain. There's basically a layer 0 blockchain that provides security, right? And then all these other blockchains, which are called parallel chains, parachains, connect to it, and each provides something to the greater good, to the ecosystem, right? So parachains are nothing without the relay chain, because the relay chain provides security, but the relay chain it's nothing without the parachains, because a lot of people don't really know this, but you cannot build applications on Polkadot. You can't. It's not an application blockchain, okay? And so that's why you need parachains. And because this architecture, you have something called XCM, which is a language for these parachains to communicate with each other, all right? To talk under the same consensus umbrella, which is great because if you think about Wormhole, about Axelar, about all these bridges, it's like one consensus, the bridge consensus, and another consensus, right? So it's like there is a weak point in that chain of consensus, right? In this case, everything happens under the same consensus. So if you're already trusting the Polkadot consensus, should be all good, more or less. So Basically, the idea here is that on Moonbeam, you can interact with Solidity, as you saw before. I can create an incremental smart contract or whatever, but there's also a lot more to Moonbeam. There's also the substrate side, the part that it's not typical from a Geth implementation, from an AVM implementation. I was showing you guys that you can batch transactions, you can do XCM calls, you can communicate with other blockchains using a Solidity interface, right? That's why I was signing with MetaMask, for example. And so the way that this works is that you have a series of precompiled contracts that they're all there in the application and that are in the resources that I've shared with you, that are basically provide an interface with a series of functions that can tap into these more complex operations, right? So that's why I had a function called transfer, which was actually transferring tokens to another parachain. It was not transferring tokens from Alice to Bob, which is that's an EVM thing, okay? And so precompiles are really powerful because that's what sets Moonbeam apart, or it's like differentiates Moonbeam out of all these like EVM blockchains that exist out there. We have a lot of custom stuff that are really cool, and the idea is that you guys start exploring them. There's a huge list of precompiles. I'm not going to go through them because, you know, for time. I was explaining here basically how XCM works at a very high level. This is not really mandatory if you want to go in the bounty, but as a curiosity, XCM is basically a message from a chain A to a chain B. The message is a series of instructions that by themselves, they don't do anything, but the combination of instructions is what the result in a given action, okay? The typical example I always say is that if you want to turn off the lights, you don't just stand up. By itself, that doesn't do anything, right? It burns out a few calories, but it doesn't do anything. If you want to turn off the lights, you have to stand up, walk, that's another instruction, and then flick the switch. Those are 3 instructions to turn off the light. That's similar to XCM. So you have, for example, 4 instructions so that you can do something on the target chain. Going back to this, right? The way that we present these instructions to you guys is through precompiled contracts. You don't have to type the instruction yourself. You just call this function, and that function will grab this 5 XCM instructions and pile them in a way that you don't really care. You just have to configure that, put the parameters correctly, but you don't really have to like know the complexity of the instructions themselves. So I think this is probably the most important slide for you guys to understand, is that the way that remote execution works on Polkadot, it's via, once again, this series of instructions. But if you go into an example, basically you have Alice on Polkadot, and she wants to execute some stuff on Moonbeam. Let's say she wants to call an incremental contract and increment the value by 1, right? So the way she would do that is basically create an XCM message with some instructions that are going to use a transact instruction. And it's going to provide some bytes that for Polkadot, these bytes don't mean anything. It's like, you know, Chinese and Japanese or Spanish and English, whatever languages, right? They don't mean anything to each other. But if you grab that message in Spanish and go to Venezuela, my country, and you say it out loud, people are going to understand you, right? So that's how XCM works. You grab the bytes, you put them in the message, and then when that message gets executed on Moonbeam, these bytes mean something. They're like, go to this contract and increment it by 1, okay? And the way that this is executed is through a special dispatcher called the multi-location derivative account. And this is basically the message, in the context of EVM, is the message sender, all right? Because Alice on Polkadot doesn't really have like an account on Moonbeam. And the way that this works is that we create an account for her via this special mechanism called multi-location derivative account. And the way that this works, and with this probably I can stop for some questions as well, is that imagine Alice, you don't really care what type of account she uses, you don't really care what hashing mechanism or cryptography they use, you don't really care, maybe it's not Ethereum compatible, right? But if you grab something called the multi-location, which is a way to represent things in Polkadot, right? In general, you can represent my shoe if it would be on the blockchain. You can actually hash that multi-location because this multi-location is unique to Alice on Polkadot, okay? If Alice exists on another blockchain, let's say Manta, the multi-location will be different. And so if you hash the bytes of that multi-location, in the case of Moonbeam, you cut it to 20 bytes because Ethereum accounts are 20 bytes. You have an Alice-derived account, which is now Ethereum compatible, right? The length of the account is now Ethereum compatible as well. And the hashing that we use is Blake 256. And so now Alice, once again, Alice has an account on Moonbeam, which she controls only via XCM. She doesn't know the private keys of this account. It's keyless. Okay? But the important thing is that when she sends an XCM message with some instructions, she can actually dispatch code from this account. And because she's dispatching code from this account, she needs to have money on that account, right? Because if you're going to dispatch a contract call on the EVM, you need to have money to pay for gas. Exactly the same concept, okay? So that is why in the demo that I was showing you guys, the first action that I was doing is transferring tokens to my multi-location derivative account so I can pay for the stuff that I'm going to do later on, okay? I don't think this is important to go over. These are multi-locations explained. This actually was in our workshop that we did on December. I actually explained them as well if you want to check that video out, or I am here if you have any questions. And last but not least, I'm not going to go through this as well. I think this is more or less well explained on the comments, but this is how you build multi-locations on, for example, the dApp that I've created for you guys. This is how you basically feed them into the smart contracts that allow you to do X tokens, like transfer tokens to another parachain or remote transact, okay? So this is how you would build those multi-locations, basically. Yeah, and this is how you create the transact data, like what I was saying before. Let's say you want to do, a balance transfer on Manta. You need to have the bytes that represent balance transfer on the Manta language, right? And this is basically how you do that. You create the API, which is like the Web3 provider in Ethers, and then you put .tx because it's a transaction that you want to do, and then you put balance transfer, which is a function that you want to invoke, okay, with these inputs, right? These inputs can be anything, but basically this is what I did for this example. And then using method to hex is how you get the call data, so the bytes that represent something on Manta. And this is what you feed into the contract, basically. And yeah, what I was showing, and I think by then you were here already, is this application. It's xcm-demo-moonbeam.netlify.app. This application should help you get started on the bounty, because you only have a few hours. So, you can use it, you can not use it, you can whatever you want, you can fork it. It's a GitHub repo. I think the code is here at the bottom. Yeah, the code is here at the bottom if you want to use it or fork it or what. Oh, there's already one fork, huh? You guys are quick. But yeah, like I said, I made some minor changes recently, but you can use it, you can ask me questions. I know it's a lot to digest because this is very different to like a typical Ethereum application. But yeah, this is the point of hackathon. I'll be here to help. I'm sitting in the booth there with the Moonbeam logo and the Polkadot logo. And if you have any questions on the Manta side, even though they're not here, Georgie is active on Telegram. If you have any specifics about the Manta SDK, I think his contact should be in the bounty sheet here at the bottom. It's GoGoMGZ. So basically, Georgie and I are the people, the couple of people that work a lot on this. So that's why you can ask us if any questions. And yeah, I'm happy to answer any other questions here that you might have, or if not, we can just meet in the booth. Is there any other question at this point? No? No, go for it.
Some examples of what you could do on Manta.
I should probably take my Manta t-shirt here. No, I'm just kidding. No, but actually because I work with them for so long on this, you can do, like the typical things like private payments, right? So you can bring your public assets. Let's say, I bring my dev tokens on Manta. I can privatize them, right? I can create them as a private asset, and then I can do a private payment, right? I mean, remember that privacy, I'm not an expert. I might be shooting myself on the foot here, so sorry if I make a mistake. But even though all the movements that are traceable on Moonbeam, and they're going to be traceable when you send them to Manta, the moment that you put them on the privacy layer, that sort of link is lost, right? And so you could then, send it around, do whatever you want, and then when you take it out of Manta, as long as you do it in a sort of like, genius way, because if you put 1.2345 and then you take out the same amount, it's going to be probably traceable. But if you do it in a way where it's just not traceable, even though you move your money back to a public ledger blockchain like Moonbeam, traceability is going to be lost, right? So at least you have still, you can conserve the privacy even though you go back to a public ledger blockchain like Moonbeam. I know they're doing a lot of stuff on SBTs, and I learned about them like a week ago. So like I said, I'm not a privacy expert, but this soul-bounded NFTs. And so you could also mint these NFTs on Manta from Moonbeam using this keyless account, which is pretty cool, right? Because you could create experiences that are based on this Ethereum-based blockchain application layer like Moonbeam, but they're using privacy powered by another protocol, basically via XCM. So I think these are the two things that they have been quite big on. Basically this Manta Pay, or this like private payment system, and the SBTs. So yeah, I would say probably focus on these two things on the bounty. Anything else you would have to ask them, to be honest. Cool. Yeah, so thanks a lot for attending. Like I said, I'll be around. So yeah, ask me any questions that you have for the bounty. So thank you.